Washington State University. Go Cougs!
Hello everyone. In this video, I'm going to cover Lesson 6 of our Working with Activity and Health Data module. We're going to talk about how to visualize aggregated data in this lesson. In our previous lesson, we were working with the Parkinson's disease Healthy Older Adults Activities data set. We're going to continue working with this data set in this lesson. So let's go ahead and load this data set back into memory in a data frame. I've already added this code here. So this code is going to open the file and it's going to set the index columns to be 0 and 1 so we get that nice hierarchical index again. I'm also going to add, after we read in to the data frame, code to create our two groups of HOA and PD classes by using the group by method. So go ahead and run this. Looks good, was able to find the file. So now let's think about how we're going to visualize this data. We have 9 different tasks, and for each task we have 2 duration distributions, one for the Parkinson's disease participants and one for the healthy older adults. So what I want to do is I want to construct 2 different types of visualizations, box plots and histograms. These are both really great for visualizing a distribution. We're going to construct a box plot and a histogram for each task in the activities data set. So there'll be 9 box plots and there'll be 9 histograms. Now on each plot, I want a separate box or a separate curve for the HOA and the PD groups. So there's our aggregated data in terms of our 2 classes, PD and HOA, and we're going to plot these 2 distributions for each task. So in sum, we're going to make 9 plots for box plots and 9 plots for histograms, total of 18. So let's go ahead and get started preparing our data for this box plot and histogram code. So the first thing we're going to do is we're going to construct a dictionary of task dictionary pairs. So let's go ahead and make task distributions be assigned an empty dictionary. So the empty dictionary we're going to populate with 9 key value pairs. The keys are going to be tasks and the values are going to be dictionaries. So for task name, in set df.index.get level values task. What set does here is it drops all duplicates. So we're going to get all of the task values, which is going to contain many duplicates, 75 duplicates for each task, about 75. And it's going to construct essentially a set of 9 different task labels, which we're going to iterate over. Then we're going to have a dictionary, which is going to be of class series pairs. So for example, HOA is going to map to a series of durations for the healthy older adults for this particular task, and equivalently for PD. So let's go ahead and iterate through our 2 classes that we've already gotten from our group by and our previous code cell. So for class name, class df, in classes, we're going to go ahead and get the duration distribution, which will be the class df.xs task name, selecting from the task level. and this will be a data frame that we will index into the column duration to give the duration series. So now all we have to do is add this key value pair to our distributions dictionary. So distribution subclass name is going to get our duration distribution. So now once this inner loop completes, then distributions has two key value pairs in it. The keys are PD and HOA, and the values are series representing the durations for these two different classes. So let's go ahead and add to task distributions, subtask name, this distributions dictionary. Go ahead and run that, and now we are ready to start creating our plots. So what we're going to do is we're going to iterate through our task distributions dictionary for each task, and we're going to pass the name of the task and the dictionary storing all the distributions for this task into plotting functions. And I've already included our plotting functions. For the sake of time, I'm not going to derive the code or describe it, but I highly recommend you read through the code and take a look at how I'm constructing these box plots and these histograms. Much of this code here is making the box plots look pretty, so we're going to go ahead and use this code to make some pretty plots. So we're going to go ahead and iterate through each one of our tasks and task distributions in our dictionary. So for task name and distributions in our task distributions dictionary, we'll go ahead and call plot box and whisker for task name and distributions. Once we've made all 9 of these plots, then we'll go ahead and show them all at once. So Jupyter Notebook will nicely put all of these plots in a little scrollable region in our notebook. So let's take a look at the first plot here. So on the x-axis, we have population for our two groups, healthy older adults and Parkinson's disease, which we see there are 48 tug durations for HOA, and there are 24 tug durations for Parkinson's disease. On the y-axis, we have duration in seconds, and we see that this whole plot here is for performing the tug, the timed up and go. So we see that the healthy older adults, they have a much tighter distribution with no outliers. Whereas when we look at the Parkinson's disease distribution, we see this wide spread of values by the outliers. So let's take a look at a few more. So here's our cook task. So our healthy older adults have much lower duration for cook, whereas the median and our whiskers and our outliers are higher for our Parkinson's disease group. Now we can go ahead and look at all of the tasks, but I'm going to move on to our next plot. Copy this code. Our next plot is going to be a histogram with a normal curve that would show an approximation of the histogram if the data was assumed to be normal. So here's the code here for plotting the histogram. All this code here is working with setting up the histogram, and this code here is working with setting up our approximate normal curve using the norm probability density function from matplotlib.mlab, which is simulating some MATLAB functionality. So let's go ahead and paste our code, run the code, and take a look at our histograms. When there's a star here, we know that the code cell is still running. When it changes to a number, looks like it is done. All right, so here are our really nice histograms with our normal probability density functions plotted here. So blue is healthy older adults and red is Parkinson's disease. So we can see that more tighter distribution for perform tug with questions duration is visible for healthy older adults, and much higher frequency bar here. And we can quickly inspect blue versus red and see similar findings. Wow, especially for the water plants duration, much tighter distribution here. Same with Cook, a little bit inverted here for day out task duration. Sweep and desk, we see something similar, and perform tug and wash countertops and fill medication dispenser duration. So these are really great plots, and I particularly wanted to show these two types of plots, box plots and the histogram plots, because they're really great for visualizing the distribution, but also because these are real-world plots that we have included in papers. So here I've just included a screenshot of a paper that was written in 2015 by our research group, where we used this same code to create Cook and perform tug task duration plots for box plots and histograms for Parkinson's disease and healthy older adults.